For section 2.3, we're going to be working with factoring equations or quadratic equations, and it's going to be important that you remember how to factor from Math 2. So we created a worksheet that will help you do this. There's lots of types of factoring, and that's oftentimes why students find it confusing because there's so many ways to factor. The only way you're going to get better at it and find it less confusing is by doing a ton of them. So we've created a worksheet here where you're going to get to practice every type of factoring, and eventually in section 2.3 we'll show you why it's so important to use it when solving quadratic equations. So let's look at this first part, multiplying. We're just going to start by going backwards from factoring. So instead of factoring, we're going to actually distribute or multiply. I'll try one right in the middle here. So when we are multiplying a monomial, one term here, by a binomial, two terms, we're going to multiply through here. And I think of it as the rainbow method or the distribution method. We're going to take 4x times 2x, and that will give us 8x squared. And then 4x times negative 5 will give us negative 20x. Not so bad. Your teachers may have taught you the box method, and you don't have to use it, but you can always put your monomial out there and your binomial on the top, and basically think of what is 2x times 4x, gives you 8x squared, negative 5 times 4x is negative 20x. Gets you the same answer, but a little bit of a visual way to represent and make sure you don't miss anything. The next section, we wanted to practice factoring. So now you're given the answer, the standard form, if you will, and you need to factor it. So we're going to look at, again, maybe example B here. Your first idea when you're looking at any of these is to find something they have in common. I notice they both have a negative. I notice they both have an x. And you have to think what number would go into both 12 and 27. Well, 3 happens to be the highest number that is a factor or goes into 12 and 27. So now I have to think backwards. 3x times what in this bot would make negative 12x? I want to keep it a positive, and a 4 times 3 would make 12. And I need another x, because remember, x times x is x squared. Now I also would have to take negative 3x times something to give me negative 27x. Well, 9 times 3 is 27. I already have the x there. Since it's negative already, I want this to be a positive. I can always check my work by remultiplying that negative 3x back in to make sure I get the same answer as I started from. Now we'll use those boxes, but we're going to be taking a binomial, two terms, times another binomial. So a 4 square box or a 2 by 2 will be necessary. We've worked with things like this in section 2.2, where it's important to rewrite that as 2x minus 1 times 2x minus 1. So since I've invested my time here, I will begin by using the box method this time. If I put 2x here and the minus 1 there, I'm going to do the same thing because it's the same binomial I'm multiplying. And now I will do the multiplication inside the box. 2x times negative 1 makes negative 2x. 2x times 2x would be 4x squared. Negative 1 times negative 1 makes positive 1. And negative 1 times 2x makes negative 2x. So my final answer will come from combining any like terms in this box. I would have 4x squared minus 2x and minus 2x combined to make negative 4x, and I have a positive 1. Note that it's still possible to do this without the box method. You would just be taking 2x times 2x first. 2x times negative 1 gives me negative 2x. Negative 1 times 2x, and negative 1 times negative 1. You can see all these same 4 terms in this box, so they will combine to the same thing, but the box kind of helps you make sure you don't forget any of the terms. Oftentimes students might forget one of these rainbows or forget which one they've already multiplied. So again, just to start setting this one up, you'd have 3x minus 6. Now you can note I did go in a different order, I guess, to keep that uniform. I could put my x on the bottom consistently, so I could do 3x minus 6 and then x plus 12. I would simply fill in what the multiplication of the two terms on the outside would be. And 12 times 6, so minus 72. So I would be combining my terms to give me 3x squared plus 30x, that's taking 36 minus 6, and minus 72. our next type of factoring, we are going to, or that was multiplying, I'm sorry, that was multiplying out here. So again, we multiply practice going forward. We take a factored term and give us a standard equation. Now we're going to use a standard equation and try to think of what it was before it got multiplied. So these ones are a little bit easier because most of the terms have the a as 1. That means the number out in front of us here is 1. Now, to be clear, this one you're like, that's a 2 there. If we take the common factor of a 2 out of all of these, I will have x squared, because 2 times x squared is 2x squared. I'd have a 4x here, because 2 times 4x is 8x. And I'd have a minus 12. So while this one looks like the 8 term's a little trickier, it's a 2, we can always pull out that 2 if they all have that common factor. So this now would become my factorable quadratic. So we're going to, one of the ways you can do these is by guessing and checking. So if we just set up, we'll try B here. If I set up 2 parentheses, because remember from the last slide when we were multiplying, we noted that when we were multiplying, you would just multiply the first terms, the outside terms, the inside terms, and the last terms. We're trying to figure out if we had this answer, how do we get back here? So now I'm going to take the standard form and think, gosh, what times what would give me that x squared? There's my x times x. What would multiply to give me 7? What would go in these last 2 things? Well, there really is only one set of factors that gives us 7, 1 times 7. If I put a plus sign in here, you could just check. X times x is x squared, and 1 times 7 is 7. But if I multiply my outside terms, 7 times x, and my inside terms 1 times x, and add those together, I do get that 8x. So my final answer for factoring with that a value here is x plus 1 times x plus 7. Be careful on this guy down here. This is x squared minus, or plus I could say, 0x minus 25. You'd be thinking of x times x and something to multiply to give you negative 25. How about a plus 5 and a minus 5? So now my middle terms, would 5x and negative 5x add to 0? We'd be good to go. That would be my original multiplication problem. The last slide had most of the quadratics with an a value of 1. They do tend to get a little bit trickier. So there is a box and diamond method that's used a lot of times, and this can be helpful when trying to organize your thoughts. So what we always want to take is our first term and our last term and multiply them. So I'm going to times those together. Whatever I get, this would be negative 15x squared, I put at the top of this x. Now my middle term here is a negative 2x. I just simply put that one at the bottom of the x. Then I always, in my box here, I always put the first term in the bottom box and my last term in the top box, top right box. You are going to try to think of 2 numbers that multiply to the top answer in orange and add to the bottom number in purple. So let's think of what would multiply to negative 15. Well, 5x and 3x come to mind. But I need one of them to be negative because I need to. So once you have this 5x and the 3x, we know that one of them has to be negative. And we were going to make our 5 negative because if I take negative 5 and add 3, I get negative 2. Now you simply put these blue numbers in any of the boxes. It doesn't matter which one. And now our goal is to go on the outside of the boxes and think of what would multiply to give us 3x squared. So I always start in the x squared bucket. X times x will give me x squared. I need 1 times 3 to give me 3. You will want to choose to put the 3 in a specific spot because if 3 goes here, we can take 3x times something to give us 3x. If I were to put the 3 at the bottom, 3x would not multiply by something to give me a negative 5 if it had to be a whole number. So if I put my 3x times x, I get 3x squared. But now 3x times what number on the outside would give me 3x? That's a 1. And x does appear up here in the 5x, negative 5x, but I need a minus 5 out here to complete that multiplication. Magically, your answer appears on the outside of your box. 3x minus 5 times x plus 1 will be your factored form. Now, with a little bit of practice, you'll get this pattern down, but one thing we can do, just so you know it's not magic, and it really does work, 3x times x would make 3x squared. 3x times 1 is 3x. Negative 5 times x is negative 5x, and if I took 3x minus 5x, I do get negative 2x. Negative 5 times 1 gives me negative 5. I know that this green factored 2 binomial equation there is my factored form for my original. One thing you could also do, if you graph your original and you graph your factored form, they should line up right on top of each other. There's one more method called factoring by grouping. We'll still implement that diamond part of this diamond box problem. So we're going to take our first two terms and multiply them by each other. So we're going to take 3x squared times negative 5 to give us negative 15x squared. And our middle term still goes in the bottom. So our negative 2x goes down here. We're going to think of two numbers that might multiply to negative 15 and add to negative 2. I always like to think times to the top. Lots of t's, but it's going to multiply to that top number. So again, like the last problem we just did, if I take negative 5 times positive 3, I'll get my negative 15, and it will add to negative 2x. Now again, it's just like the last problem. You could continue with the box, but for factoring by grouping, we write our first term out in the beginning, leave some space, and write your last term out at the end. In purple, I will bring in these two terms that I put on the side of my diamond. So minus 5x and plus 3x. It doesn't matter which order you put them in. And what we're going to do is factor by grouping. Like it said, we're going to group the first two together and the last two together. If I look at these first two and find a common factor, what do they have in common? Well, 3 and 5 don't really mesh well, but they do both have an x. So I'm going to take an x out front and think x times something to give me 3x squared. Well, that'd be 3x. X times something to give me negative 5x. That'd be a minus 5. Now over here, gosh, they don't even both have an x in them. They don't have 3 and 5 go nothing together. The only thing they have in common is a 1. So I'm going to take out a 1, and 1 times 3x would make 3x, and 1 times negative 5 would make negative 5. But notice right here how I've created the bubble, if you will, with the same term in it. Now we're going to factor within our factoring. We're going to take this common pink bubble out as one factor and say, I have removed that from all that green equation right there. What's left over? So I've got this x. I took 3x minus 5 out. I left an x, and I left a plus 1. Right there is our answer. If you compare this to our answer from the last screen where we did the exact same problem, you'll notice we got the exact same answer, so we know it works, but we did it a little bit different. So again, to remember, we multiplied our first and last term at the top, our middle term in the bottom. We thought of the two numbers that would multiply to the top but add to the bottom. We wrote them out, doesn't matter where you put them, and take out what they have in common, grouping them 2 by 2. Finally, when you see the common term in the parentheses, you pull that out front and write your leftovers in the second parenthesis. You'll need to factor frequently and become quite good at it in order to solve the quadratic equations that we'll be working on in 2-3.